With that being said, I'd like to get started here. Thank you all for joining us today. I certainly do appreciate it. My name is Daryl Dankert. I'm with Williams Sound. I'm the International Technical Training Manager, and I'm also part of what we call a Tech Blue team. Tech Blue is our tech support department, where we would do any drawings, which I'll talk about a little bit, which is the ease modeling, anything that you might have for induction loop systems. We will do drawings for induction loop systems. We do all of these free of charge. There's three of us. There's three of us in the Tech Blue department. I've been with Williams Sound for about 15 years. A couple other people have been here a bit longer than me, but I am in the international department, so this is particularly the reason why I'm hosting this webinar, because of all of you in London. So my information is up on the website, or up on the webinar right now. You've received 2 emails from me in the past couple of days, so you have my email address as well. If for some reason you have any questions and would like to talk to me directly, you have my information. Otherwise, I would probably recommend going through CUK first to see if they can answer any questions first. So with that said, let's get this party started. We're going to talk about infrared today. I'm not sure how familiar you are with infrared. Infrared is probably our second largest technology as far as sales go in Williams Sound's catalog, FM being the first. I'll go through a couple different models that we have, but I'm going to go through a very generic infrared technology throughout everybody's categories or catalogs. So basically, infrared is audio carried on a light that's not visible by the human eye. I'll go through a couple of different scenarios for that as well. But most of the infrared that you would find on the market works or operates on 2.3, 2.8, 3.3, and 3.8 megahertz. There are some other frequencies available out there, but most commonly those are the 4 frequencies that you'll find by all the manufacturers using infrared. Just to kind of give you a comparison between FM, IR, induction loop systems, this is a chart that I've kind of put together showing you a little bit of a difference between infrared, FM, and induction loop. So does the receiver accept a neck loop for users with hearing aid T-coils? So the answer is yes, yes for FM and IR. Mostly depending upon what type of receiver they have. Some receivers may not have an ear jack or a headphone jack to accept a neck loop, but most commonly you'll find that they do have that ear jack or headphone output for a neck loop to be plugged into. As far as an induction loop system go, you probably already know that if they have a T-coil, all they have to do is walk in the room that's looped and turn their T-coil on the T-coil position or the microphone and T-coil position, depending upon the manufacturer, depending upon the technology, how new or how old that hearing aid might be. Relative cost of installation for a new building, we say low for FM. Whether it's new or old, there's nothing that needs to be taken up, like the carpeting for an induction loop system. Infrared is a little bit higher cost depending upon the size or the area that needs to be covered. And then also with induction loop system, it's a little bit higher, first of all, because of all the wire that's needed, as well as the labor to lay down that wire. Can be used for applications beyond assisted listening, such as audio description, language interpretation, or other needs or uses. FM has multiple channels. Most companies you'll find have roughly 17 FM channels available. Some infrared, you'll find 4 channels up to 32 channels depending upon the manufacturer. And as you probably know, induction loop is really only one single channel, where you may mix like an emergency page or something into that, but really it's only used for a single channel for audio on induction loop systems. Maximum number of simultaneous channels. With the FM, it really depends on the manufacturer. Williams Sound has up to 8 channels simultaneously. Other manufacturers specify 6. And again, depending upon who you look at, you might find more channels available on FM that can be used simultaneously. With infrared, as I mentioned, there's up to 32 channels available with infrared. Through some manufacturers, Williams Sound does not offer 32 channels of infrared. Maximum number of simultaneous channels for induction loop, obviously we just talked about one single channel. Secure signal, basically meaning is the content kept or maintained within inside the room, closed walls if you will. FM, as you know, works the same way as your car or home radio. You're picking up a frequency or a channel from an antenna or broadcast station and listening into your car or home or at work or whatever. So in reverse, how FM works is there's this transmitter in a house of worship, classroom or education facility, something like that. It is not contained or maintained within that room. So there is what we call bleed over or overspill or broadcast outside of the room. Infrared is probably the only technology that we can say with more certainty than other technologies that it is contained within a room. Because it is light, it does not broadcast out or through a solid wall construction. Now, this could be argued if it's a meeting room that's got glass walls or something like that. That's where your secure transmission may come into question. So just keeping in mind that infrared is contained within a room that has a solid wall construction. As far as an induction loop system goes, you can minimize or reduce the possibility of broadcasting or emitting a signal outside of a room, but it is not 100 or completely secure transmission outside of the room. Audio quality, if you look at the specifications, you'll see that there's a bit of a difference between all the 3 technologies that are up there. I won't say which one is good, bad, or best. It's all going to depend on the audio that's coming into the system, and it's also going to depend on a person's hearing loss. But by specifications, if you look at it, FM is probably your better sound quality for frequency response, whereas loop might have a lesser or not as well received frequency response. But again, we're talking about someone's hearing loss, how that hearing aid is programmed. Some people feel that the loop system has a much warmer sound than possibly an FM or an IR system. So I'm not going to say or throw out any opinion at this point, but just looking at the frequency response, that's basically what you'll find for specifications. Interference with equipment within the facility. FM is really set. The frequencies are really set for hearing assistance. Here in the United States, we have 72 to 76 megahertz set aside for hearing assistance, interpretation, audio description. So by FCC rules, we are not allowed to interfere with any other equipment, and other equipment is not allowed to interfere with us, but we all know how wireless transmission works, and there's also the possibility that there can be some interference from something in a building, but by general rules, there shouldn't be any interference with FM. Infrared, the earlier stages of infrared used to be on 95 kilohertz or 250 kilohertz. Those frequencies, we found that there was some interference with fluorescent lighting. There's also the possibility with the newer frequencies, interference with the sun, which we all know is probably the largest emitter around. So there are possibilities, but there's also the less likelihood of interference with those two technologies. Induction loop systems, there are possibilities depending upon how old the facility is or how new the facility is, what might be in that general room. We're talking about like on a stage for a house of worship or something, if they're using guitar pickups, if they're using older dynamic microphones, even some older dimmer switches for lighting control. So that's why we say yes, and it's possible, but there's also ways to work around it, but not in all cases. Can hearing aid users use the system without additional equipment? That again is questionable, but hearing aid users use the system without additional equipment. We say yes with an induction loop system. Obviously, the hearing aid user has to have a T-coil in it. So keeping all that stuff in mind, there's a chart. Does anybody have any questions on this where they might want to make any comments or recommendations or any other thing that they would like to add to this? Again, I do have the chat box open, so if you are uncomfortable asking a question with the microphone open, feel free to type in the chat box. Otherwise, I really encourage any interaction. Open up your microphone, ask questions. No? No questions. All right. Moving on. So why do we want to use infrared over other technologies? First of all, we've got to consider the budget. We have to consider the structure of the building. Are you capable of running wires in a wall? Is it a historic facility? Can you run infrared? Infrared light, as we talked about, cannot penetrate walls or ceilings. So when we say no license is required for infrared, for the UK, 863 megahertz is a free frequency to use for hearing assistance. As I spoke about here in the US, it's 72 megahertz. So when we say that there's no license requirement, the frequencies 2.3, 2.8, 3.3, and 3.8 is worldwide license free. So you're not needing a different frequency or channels for different regions of the world. Portable infrared hearing assistants are a little bit easier to set up than a permanently installed one. I'll cover that in a little bit, but there's some smaller units which are considered portable. They fit on a camera tripod or can just be moved quickly from room to room. Multi-channel systems are available, as we talked about on the first chart or the last chart that we were just looking at. Cinema is really probably the biggest market as well as courtrooms here in the US for infrared, particularly because the audio is contained within that room, and it's considerably less expensive to do these rooms that are side by side versus an induction loop system where considerable designs are needed, as well as a lot of testing to ensure that you're not leaking audio or spilling audio into the next multiplex theater room, or specifically here in the US, they won't use induction loop systems in courtrooms because it can spill outside of the court proceedings, and that's basically what they call a violation of the what am I trying to say? Violation of the defendant. Courtrooms are typically using it in the council chambers, the deliberation rooms. They'll use the smaller portable infrared systems that match the same frequencies that are used in the courtroom itself. So the people that are using the equipment in the courtroom simply walk into the council chambers or conference room or deliberation room, and they don't have to change channels or frequencies or change from an FM receiver to an IR receiver back and forth. So that's particularly one of the reasons why they like that product. Twin channel receivers are used by the delegates to listen to either the interpreted language or the floor language. What I mean by that is because you can do multiple channels on a single emitter, you can do the floor language, which we would say is what's being the common language, let's say just English for our practical purpose here. And what might be an interpreted language might be Spanish or French or any other second language where someone needs interpretation during the court proceedings. Those are all done with the same emitter. You may have to add a second emitter depending upon the size of the room or facility, but most commonly it's all done on the same emitter. Twin channel systems can be used for stereo sound applications. This is the only technology that Williams Sound has available, and many other manufacturers have available, that you can actually do a true stereo broadcast with the technology. With FM, you could do a mixed mono signal, if you will. You could do it with induction loop systems, but if you want a true stereo left and right separation on a technology, infrared's the only one that can do that. So instead of doing English on 2.3 and Spanish on 2.8, you might do the left audio on 2.3 and the right audio on 2.8. So how does infrared work? What's the difference between analog or digital? And before I go on any further, is there any questions about the last stuff? One new attendee coming in a minute. All right. Max did not get the invitation. I'm looking at my list of attendees here, and I'm not sure if I have a Max Hooper. I don't see him on my list, so I apologize for that. We can wait for him if you'd like. I'm assuming that you sent him the link to join us. Sorry about that.
That's all right, Darren. That's right. He just rang the office. I think it went into his junk folder, to be fair. So I've resent it to him, so he should be joining us in a minute. Here he comes.
Do you want to wait, or?
I think he's just registering now, looking at the list of people.
Okay. All right. We can wait.
Or he may decide to remain anonymous as 2014.
Yeah, his name will come up as soon. There he goes. He's here.
Okay, thanks for that. As you were then, Daryl.
Say again.
Off you go when you're ready then.
All right. Well, thanks for joining us, Max. I'm terribly sorry you didn't get the invite. You haven't missed a whole lot. So if you need to catch up on anything, feel free to send me a chat or ask a question, open up your microphone. We're just now starting on how infrared works. What does it do? What's the difference between analog and digital? So examples of analog infrared. You could look at a couple of different scenarios. Any of you work with security cameras, those are basically analog infrared to light up the area where the camera needs to see. So it's basically looking through the darkness using those infrared LEDs. thermal cameras. Not sure if any of you have worked with thermal cameras, but there's an image there that you might see the difference in the temperature of a structure, whether it's a building or an animal or landscape, whatever the case may be. And as I spoke a little bit about medium-size, mid-range, or portable infrared, there's a couple examples that I've got up here. Top one being the Williams Sound TX75 emitter, the bottom one being the Sennheiser SI30. And then I'm sure some of you may have or even know of where space heaters are used, infrared space heaters. You probably even came across or might even be using the new infrared ovens or even the grills for cooking. Some examples of digital infrared is your television remote. So if you're not familiar with how this really works, if you look at a digital or your television remote, all those buttons have a different command, and how does the television know what you're asking it to do? The digital infrared has a code, or it'll flash codes at the television saying this is volume up, this is volume down, this is channel up, channel down, mute. They all have a different flash code for those different commands. Digital thermometers for the ear temperatures. If you've been to a physician or doctor that might use this on a child of yours or a patient that you might have seen this being used on. Hearing assistance, this is where we get into our up to 32 channels of infrared. Sennheiser probably being the biggest market with the multi-channel or the digital infrared. The digital infrared doesn't give you any better sound quality or range, but it does give you more channels, is really what it comes down to. And then if you've ever used a digital thermometer to check a room temperature or what the temperature is coming out of a vent, this is the illustration there for that, the digital thermometer. So multiple different uses for infrared and analog or digital. So one of the things that we do in the TechBlue department or tech support when we're talking to customers that have infrared, we know that ours is analog. Those lights remain on constantly as long as there's audio present. A few minutes after audio is gone or no longer available, the LED lights that are emitting that signal will shut off, but power to the unit will remain on. One of the things that you can do with either digital or analog is put your cell phone in camera mode. Those of you that have iPhones will have to use the selfie camera. Those of you that have Androids can use either camera, but iPods have a filter on the other camera, not the selfie one, where you won't be able to look at LEDs on an infrared unit. But if you got a digital camera or digital video recorder or something, take a look at the emitters or your TV remote where your diode is, and basically press a button on your TV remote, or with the emitter in the room, you can look at the lights and see if all of the lights are on. Looking at your TV remote, you'll know if the battery's dead or not by pressing a button. If you see the light flashing on your TV remote, you know at least your battery is good. So something else might be the problem why your TV isn't changing the volume or channel. But basically, that's how you'll know the difference between analog or digital. Analog is on constantly as long as the audio is present. Digital, as long as you're pressing a button or asking it to do a command, those lights will flash. That's one of the reasons, and particularly the one big reason why TV infrareds don't interfere with our analog infrared. So, looking at it, I showed you the illustration as you were coming into the meeting, but analog, if you look at the section in the middle where people are seated, it's kind of a cone shape where we might say this is the dispersion pattern of the emitter. As an analog, those lights are on constantly. If you look at a digital one, such as this one, now I kind of slowed it down and sped it up a little bit so it doesn't look so terrible, but that gives you an idea what a digital infrared signal would do. Okay, so analog is on all the time. Digital is a flashing code, or it's flashing while it's emitting. All right. So the different categories for infrared, as we spoke about, primarily hearing assistance in courtrooms, also in multiplex theaters, basically rooms that are side by side. You might even use these in a large education facility, a campus or something like that, where you need multiple rooms, an auditorium, where you don't want the users to change receivers from an FM to an induction loop to FM or something like that. Audio description has come up more frequently in the past 6-8 years. Some of the movie producers will put another track on the film, which is audio description. So those that are visually impaired or might typically read a captioning on a film, now the theater or that venue could put the second audio source, the audio description, on a second channel of infrared, and you can say those of you that need hearing assistance, put it on channel 1. Those of you that need audio description, put it on channel 2. So they don't have to buy a second emitter, they don't have to buy a second technology, a second receiver, or different receivers depending upon their needs, whether it's for hearing assistance or audio description. Same receiver, just change the channel. Another one that's been a very popular one is for interpretation. As we spoke about a little bit earlier, we've only got the 4 channels, but if you're looking at like a UN meeting where you need multiple languages or something like that, that's typically a market that we don't play in. That's really kind of a Bosch or Sennheiser, DIS, those kind of guys that play in that market. That's their category. And one of the reasons why we really stuck with 4 channels versus 32 channels. Most of the interpretation needs that we've seen are normally 4 channels. So we're in the smaller market versus the bigger market. So when we talk about infrared coverage or categories, we break it down into a small, medium, and large categories, and you'll find that pretty true with most manufacturers of infrared technologies. Small area coverage is more or less what we would determine to be in a living room style, where it's a end user customer in a living room, or maybe even in a retirement center, a nursing facility, something like that, where it's a one person needs to hear the television while they're bedridden or being cared for, whatever that case may be. But it's really an end consumer or one person use. Mid-range coverage is more or less a category that we just been into the 8-10 years now. Kind of a category that we missed some sales in, but the coverage is what we identify as a mid-range or a mid-sized room, 12,000 square feet or about 1,100 square meter room. And then large area coverage, which you'll find on all or most manufacturers, is about a 28,000 square feet or 2,600 square meter room. Per emitter, single channel emitter, we'll go into single channel, dual channel, all that stuff here in a minute. There is a bit of a difference when you change or add more channels. in the basic sense, this is what you'll find in most specifications. Are there any questions on this? Anything anybody would like to add?
No, I'm fine, mate. Thanks.
Very good. All right. So let's talk a little bit about large area and mid area. The topic of this really would not need to cover small area, as we're talking more about installed venues. So if you look at a manual or a dispersion pattern for infrared, you might find some different patterns from manufacturer to manufacturer. So I'm just going to throw this one up here to show you the difference. When we talk about maximum coverage, as I showed you on the previous chart there, 28,000 square feet, 2,600 square meters. Depending upon the receiver, depending upon how many channels you're using, everything kind of changes as things go on. But the outer pattern, if you will, if I grab my little highlighter here, if I grab and show you this area here, being what we would consider the 28,000 or 2,600 square meter coverage plane. Again, single channel mode using the RX22 receiver or the best receiver that you might find on the market that has the most sensitivity, best capability for coverage. So the other two inside would be different receivers on the market, giving you different coverage patterns. So if you, again, on the left side, this is feet 0 point is where that emitter would be placed. So from left to right off axis, you'll see the down here you'll see left to right from the emitter if you're facing it. So basically it can go out, let's say call it 20 meters, 25 meters to the right or to the left off axis, basically 20 meters out from that. So this kind of gives you a good idea of coverage pattern and basically where we would talk about placing the emitter, doing an ease modeling or something like that for you. Okay. So if we were to use a single emitter in a single channel mode, finding that that may not cover our room well enough, we might consider adding a second emitter next to it, on top of it, in the very close proximity of it, to give us an added range or distance from the emitter. So if I had a room that was, let's say 60 meters, I might need to add a second emitter to get that distance or the length of that room covered in the back. This is just one way of doing it. Placing them near each other or close proximity to each other gives you larger coverage. We say roughly 50% increase in range. So, let's talk about 3,500 square meters versus 2,600 square meters, somewhere in there. Another way that it could be done is placing them far enough apart where you're getting that 2,600 square meter coverage per emitter. Once you've got a floor plan or a layout of that room, we can certainly help you determine what's the placement of the emitters and how many might be needed in that room. So the question that came in, I'm not sure if all of you can see the chat box, but the question came in asking me what do we have to factor in reflections? So there's a lot of things that will take place for reflections. Typically, most often, we don't rely on reflections. We rely on what we know is the factor of how these units are laid out and the actual dispersion pattern of it. If we do an ease drawing for you, that does not show reflections as well. But with that being said, the harder the surface, say a sheetrock wall, marble wall, um, the more reflection you'll get from it versus a softer material like a curtain on a stage or something like that won't reflect it. The brighter the color it is, the more reflection you'll get off of it versus the darker the color. So if you have a white wall, you'll have more reflection than you would from a black curtain. So typically and generally, I don't really rely on reflections for infrared. It does come into play helping you, but once we show you an ease drawing of the actual patterns, that does not show reflections. It does help, but I wouldn't use it as a factor saying we can get another 500 square meters out of this because we have white walls. It'll probably come up as you set it up in the room saying, well, we're getting the good signal in the back of the room now where the ease modeling said it didn't. But when we're doing the ease modeling, we don't have all the wall materials. We don't know exactly what's in that room at that point. So great question. Thanks for asking.
Yes, sorry, that came in from me. I was thinking more along the lines of can you get stuck with areas of reflections? I mean, does phase cancellation come into this spectrum at all? Is it possible to get dead spots as a result of reflections?
You'll get dead spots or phase cancellations depending upon if we're looking at this model or the drawing here that's with the 4 emitters. If these were placed in absolute perfect conditions and perfect angles, that middle spot where they all meet, where my highlighter is right now, would be considered phase cancellation, and depending upon the angle of that receiver, you'll probably get that phase cancellation, and that receiver is not going to know what signal's the strongest to pick it up from. Most often to deter that is to angle the emitters slightly different. It's the perfect storm to get them all to meet right in the middle like that, but we just took the coverage patterns and put them on a chart to show you that, to say with these angles you'd get some phase cancellation in the middle. With reflections, that's much more difficult to get phase cancellations than it would be to have the perfect storm setting up all 4 emitters like this illustration and have the very center of it cause phase cancellation. The other thing to consider too with phase cancellation is the length of the cable and how many units are actually in the same room operating on the same frequencies. So when you daisy chain 6, 7, 8 of these units, that's where you get more possibilities of phase cancellation. So you'll find some manufacturers have a phase cancellation compensation on the emitters or the modulators. Most often we say whatever cable run is the longest, all of the cables should match that same distance or length. So if you find your longest distance for cable run is 40 meters, all of the cables should match that 40 meter length. That helps reduce the phase cancellation. Also changing the angle of the emitters in the room will also help reduce or minimize that phase cancellation. Does that answer your question?
Yeah, that's great. Thank you.
Mm-hmm. Are there any other questions regarding emitter placements, dispersion patterns, coverage? If you look on the left side of this illustration, you'll see what's kind of a globe, kind of giving you a dispersion pattern or the coverage. So generally when we talk about placement of these emitters, you kind of want to place it up a bit higher. We say 3 meter, 4 meter range. I'm a fairly tall guy, so if I sat in front of Simon, I might block his signal. if that emitter was at eye level, right? So if that emitter's above everyone's head and aiming down at the audience, Simon will get that signal over me to his receiver versus me blocking it if it was at eye level. So we know it's not possible or feasible to do it on every installation, but if you can get it up high enough and angling it down at the audience, you'll get much better coverage and much more reception to each user in the seat. So, okay. All right. So if we look at the medium coverage patterns, again, this is a couple different receivers on the market compared to what would be the dispersion pattern with the medium emitters on the market. So if we look at, again, we're going out, let's call it a little shy of 60 meters, straight from the 0 mark, straight out, we're a little over 60 meters, not quite 60 meters. But you'll notice that going from left to right off axis, we're a little bit narrower than we were with our large area coverage. So this is going to, again, determine where they're placed, where we need to aim them. And again, this is the mid-range, not our large range. So looking at the dispersion pattern off axis left and right is going to determine where it's placed, how it's angled again. Okay. So going off axis, we're only, what is that, 12 meters? Something like that, 12 meters off axis. Whereas our previous dispersion pattern on the large area, we were looking at, let's go back there, 20 meters, 25 meters. Okay. So there is a bit of a difference between the two of them. We're basically the same in distance from the emitter straight out, but we're different. The medium range is a bit different from left to right off axis. And again, it's basically the same theory. If we stack or place those two emitters side by side or stack them on top of one another, you'll get about a 50% increase in range with the two emitters on the single channel mode. And again, with the mid-range emitters, if you place them side by side far enough apart, you can get up to that 36,000 square feet or that 3,000 square meter coverage with three of these mid-range emitters. So this might be something you might want to consider in breakout rooms in convention centers where you have the air walls and separate them. That's another idea for infrared. You can determine what audio is sent to what room when the air walls are open and closed. Okay. Are there any questions on the large or mid-range emitters, coverage patterns, dispersion patterns, placements, locations?
Not from this end, thanks.
All right. We'll talk a little bit about the EASE modeling simulation software. I'm sure some of you may have used the EASE modeling for speaker aiming. This is basically the same thing with infrared. It's just a module that we've worked with AMFG to put in EASE modeling. We've given them lots of information to help set up the EASE modeling in the infrared module. So just for visual effects, so we just kind of took out some simple basic drawings and placed a couple of emitters in what we would consider maybe a small or mid-sized church or house of worship. Placing in this one, I've got two mid-range emitters. If you look at the two units, the top upper blue squares is the mid-range emitters. The coverage pattern that you see here is what we place at ear level, or listening plane as we call it. So this is, what is it, 1.2 meters or 4 feet above the floor, which is what we would consider the listening plane. Oh, so one of the questions just came in about the vertical dispersion. That is different on almost any manufacturer, but in general, you can look at the mid-range emitters are generally in the 12 to 15 degree dispersion pattern, whereas your large area is roughly in the 28 to 31 degree dispersion in the vertical. So the mid-range is a little bit narrower than the wide range, large area. I can set up and show you a ease modeling with the dispersion in the vertical dispersion. That takes a little bit longer to do, but I can certainly show that as well in a modeling. Great question. I'm glad you brought it up. Thanks. All right, so if you look at the chart over here on the right, and these two emitters up on the top blue squares, you'll see that in the very front here, because we're almost underneath the emitters, our signal is fairly weak. And I just aim these straight out. I did not aim these down at a 2 or 3 degree angle. I just kind of kept it simple, easy, straight across the board for all comparisons. So right in the middle here is basically where our strongest signal is, all the way to the back of the room. Now if I angled these down 2 or 3 degrees, maybe even 4 degrees, I probably have pretty consistent coverage throughout the entire room. All right. So to give you another idea or another example of the coverage, we're going to look at it from the top. So here again are my emitters, placed right here. Okay. And then my coverage pattern throughout the entire room, which is about that 20 meter, 21 meter range. Okay. So this is using two mid-range emitters. Now if we were to take that same church or house of worship and place two large area emitters, same location, same angle, you'll see that we got considerably stronger signal strength. Okay. Again, these are placed straight out. They're not aimed anywhere. We're at the 4 foot listening plane here. Much stronger signal strength, much stronger coverage. Another question came in. Placement of the emitters would probably need to be on all walls when the seating layout in a Congress Council layout. Correct. Yep. I could have put these on the back wall of this house of worship, but for simplicity and just to change everything, keep everything consistent, I left them on the same location. What would consider to be an acceptable drop in signal front to back? So that's a very good question, and one of the things you want to look at when we're talking about the ease coverage, let me go back to our mid-range and show you on a better example here. So up here, where you see the orange and the yellow, if you look at the chart over here where we're talking 42 dB, 41 dB, 40 dB of coverage, basically we say anything below 42 dB is what we would consider lost signal, or at least minimum acceptance. That really depends on the sensitivity of the receiver, but most often if you consider a 42 dB or lower, 40, 38, 36 dB would be the minimum threshold is what we would consider. So with this illustration, obviously I just placed them as I showed here in the front. I placed the emitters. I didn't place them up against the back wall back here where I just placed them up front here. knowing that there wasn't any seating back here. This is basically a stage. I don't need to cover this stage area, so I put them in front of the stage, covering the seating area. And again, I didn't angle these down. If I had known there was seating right up front here, I could angle them down to get more coverage there. But this particular area right here is where I would say is unacceptable, or we know that we would have to change the angle of these emitters down to cover that very front 2-3 rows of seating. All right. Any other questions? Great questions. Keep them coming. Okay. All right. So back to the large area coverage. Now we can see that even the green in the front row is acceptable. I don't need to aim these down if I don't want to, but I certainly could to get the same coverage basically throughout the entire room. I could probably even put these on the back wall of the stage, all the way where we talked about putting them back here, cover the stage area, and even still cover the back row seating if I had to. So, but for my purposes here, I just showed you the same church with the differences between a mid-range and a large range emitters. Same placement, same angles, just different coverage. Okay. Very simple square church, about 20 meters in length. Okay. And again, looking at the coverage pattern from above, looking down at it versus at the angle that we looked at previously, much stronger signal. So let's take an odd shaped church and do something different with this one. We have higher ceilings, but at this point we're not too concerned about coverage. Obviously up in the rafters, we don't have any rafters or any balconies, so we're just looking at everybody seated on the main floor area. These emitters are placed right here and right here. So where you see the stronger coverage, obviously this red behind them on the red outside, left and right's very weak coverage. These are aimed directly at this corner right here. You can see that the dispersion pattern is going right straight down this line. Minimal or basically no coverage in the center here. And pretty minimal coverage, probably even unacceptable, or it is unacceptable back here. So this is two mid-range emitters in the placements, again, are right here on the corners in front of this staging area. Okay. So if we look at these from above, again, my emitters are basically right here in the corners, aiming straight down the wall here. So that's why we're not getting very good coverage pattern. All my emission is basically stopped or blocked at this wall and at this wall. Now if I aim these inward a little bit to kind of cross paths, you'd probably get some reception, but at this point I would feel uncomfortable giving any advice on using a TX75 or even any mid-range emitter in this coverage pattern. I'm new to system listening. Could you put emitters in the roof space and fire them straight down? You could. Generally, that's not the best practice, but if that's something that you wanted to do or could do, you most certainly could. One of the things that we here at William Sound talked about doing was actually making a light fixture that had the emitter in it, selling the entire light fixture and the emitter, so it was going to be in a ceiling. One of the things that we found is we had a Stetho style receiver, which I'll talk about here coming up at the end, but the receiver basically plugs into your ears and rests on your ears and goes underneath your chin. That receiver was not that sensitive, especially in a house of worship where people might be bowing to pray and stuff like that. Reception was blocked, so we basically threw that out the window and said, let's put it on the front wall or back wall or side walls where we can aim at the user versus aiming down at the user. You could certainly put it in the ceiling. There's nothing saying you can't, but keeping in mind anything that needs to be plenum rated in the ceiling, we don't carry plenum rated wiring. But yep, most certainly could do that. There's nothing wrong with it. If that's something, a project that you have, we can certainly put them up on the ease modeling and show you what it looks like. We can certainly do that. Best practice, most often they're on the side wall or front wall. Okay. Great question. All right, so again, looking at the cross-shaped house of worship with the two mid-range emitters. Again, I don't think I would recommend two emitters in this room, especially in those locations at that angle. So if we were to take the same church or house of worship and put in two large area emitters, again, they're in the same location, basically in the corner right here, aiming straight down the line. If we look at it from the top view, I've got fairly good coverage even though I'm aiming my emitters straight down. I could angle them in a bit to get better coverage here in the center. And probably if I knew where the seatings were back here, might change where the placements are, might even go towards the middle here versus right here in the corner. I might go in the middle. So just kind of give you a quick comparison again in a larger facility with the two different types of emitters, large area versus mid-range. I would feel more comfortable recommending this setup with the large area versus the mid-range in this type of venue. Okay. So if we're talking about a theater balcony, if you look at...
Sorry, Daryl, can I just interrupt you?
Yeah, go ahead.
There's a question coming from Martin about can you set the emitters in a central cluster type arrangement?
I didn't see that one.
I don't know if I can read it. It says, can you set the emitters in a central cluster type arrangement from the middle of the room, say every 90 degrees?
Oh, there it is. Okay. Central. Yes, you could. Absolutely. There's nothing wrong with that. Are you talking about like hanging them in the ceiling and angling down as well? Yep. Yeah, absolutely. There's certainly nothing wrong with that at all. Yep. In fact, there's been a couple of them that we've done that way. Costa Rica, we did for the presidential event that took place in Costa Rica. We put them in a central cluster up on the rigging for staging and dispersed them out because all the presidents were sitting basically underneath the emitter, and we did get reflection off of that because it was a smaller room, but that's how we basically did it with the presidential event in Costa Rica. Yep. Excellent questions, everybody. Thank you. Appreciate them. So this is a theater. We're looking at a balcony as well. So if you look at this portion here, would be the balcony. So the stage is up front here, if you will. I did not do this with a mid-range emitter because the coverage is absolutely horrible, and I probably should have left it in there just to show you how much different, but I figured the church that we just looked at was a good enough example. But this is showing you if we were to place the emitter in a specific location, we can still cover the emitter, cover underneath the balcony for the first row, and then also cover the balcony up on the second row. So another question came in. When you see 40 dB is about the lowest acceptable for effective pickup, does it not depend on the type of receiver being used? Yes, it does. Yep. So that's basically when we showed earlier the different receivers. When we look at The ease modeling, all of the manufacturers have put in the best case scenario with the best receiver, if you will, right? So we're taking what we know as 3-watt output from the emitters, using the best case scenario receivers. Here's what you're going to get for coverage in the single channel mode. Now, saying that, all of the modeling that we're showing you here today is done with the single channel mode with the best receiver that's the most sensitive receiver on the market. So if I go to this next one here, which I'll show you right now, you can see the gradient or the different layers or levels where that coverage would be. Again, this is the single channel mode. I can turn on all 4 channels. I can turn on all 32 channels and give you the worst case scenario with the worst receiver. But for today's practical purposes, we're showing you the best coverage with the best receiver, best practical purpose. But yes, you are correct. Yep. Right. So the previous modeling was basically showing you a very smooth transition. You kind of got to guess where that breakup is, where 49 dB meets 52 dB. But so in our modeling, we can do either one of them, showing you at each level where that break is what our measurements would be. So 2 large emitters, large area emitters covering this theater will certainly do both under the balcony and up on top at the correct placements. So what you're seeing here is basically the hearing plane or the 4-foot level for the first and second levels. All right. Any questions on the ease modeling?
Just to confirm, Darry, you don't charge for the ease plots, do you? They're free of charge.
That is correct, Simon. We do not charge for any of the work that we would do. Designs for induction loop systems, any ease modeling that we would do for you, we do that free of charge.
And what's the average turnaround time?
Depending upon what needs to be done, if we have to build that facility in the ease modeling, it'll take a few days for us to do that. If you've already got an ease model built and packed, you can send that to us and we can throw in the emitters and show you the angle and placements if you don't have that ease modeling with the IR module. Otherwise, you could do it yourself if you've already built it. Otherwise, you can send it to us and we'll do it. If you send us an ease modeling or a packed model already, generally we can get it to you that day, if not the next day.
Okay.
For an induction loop systems, I know we're not talking about it, but really all we need for an induction loop modeling is the floor plan. All of the stuff that we make for you is put on a title block sent to you with your company logo on it, the project that you're working on.
So just to confirm, when you want somebody, when an ease request comes in, you're looking for, at worst, a simplistic length, width, height, ideally construction of the room, and if it's a theatre, for example, how many balcony layers, that sort of thing, yeah?
Yes, correct, Simon. Yep. I'm sorry I didn't clarify that. Yes. If you don't have ease modeling or don't use ease at all, if you send us the floor plan, even if you got elevation plans, we'll work off of that. Both of them would be preferred if you have it. But if we can work off of something that gives us the dimensions, otherwise we typically just do a 10-foot height or a 3-meter height wall and do a 1.2 meter hearing plane like you just saw in the modelings that we did here. But we'll make the general construction off of the floor plan that you've given us and basically go from that. Obviously, the more complex, like a theater with multiple balconies or stuff like that, might take a little bit longer, but generally that day or the next day. Yep. Okay. Any other questions? Okay. We'll jump into some receivers here. You'll need to know the seating layout in case the seating is not all anything the speaker. Knowing the seating plot does help, but generally when we do the ease modeling, we're just looking at, all of this, what you're looking at here is the listening plane, or what would be that face level when they're seated. So if they're facing away from the speaker, or say they're in rounds versus classroom seating, that would take some bit of a difference in laying out the plots and laying out the emitters in the room. But if we know that that room is always changing and never the same seating assignments, generally we'd put them on the front wall or on the side wall facing. Yeah. But if you know that it's a permanent seating where, you know, some are facing forward, some are facing left, some are facing right, we can certainly work on that. Absolutely. Yep. Okay, so we'll talk about some receivers that are on the market. Earlier I talked about a unit that we call a Stetho style, or under the chin. As you can see by the illustration here, basically the earbuds sit in your ear canals and the entire receiver rests on your ears, and then the receiver itself resides under your chin. Volume control, channel selection are all on the top or top and back of the unit. The front of it facing towards the emitter, getting you the best reception. So you'll see that some of these receivers may not be recommended. And again, this might be where if you do want to put the emitters in the ceiling, this may not be the receiver that we recommend, especially in a house of worship where they might be kneeling and bending and bowing to pray and stuff like that. So all that kind of stuff needs to be taken into consideration when you're looking at different styles of receivers. Most of these you'll find on the market have a proprietary battery where you have to have a charger. You'll see in the two right ones the charger that's included in it. But generally, most often, these are not regular AA or AAA batteries. These are proprietary batteries that you need to get from the manufacturer, and you have to have a charger with these. You may find that these don't have quite the same battery duration per charge as other units on the market. There's headset style receivers. Most of these you'll find on the market use AAA batteries. So if you've got a client that's not concerned about rechargeable batteries or don't want to mess with rechargeable batteries, this might be the way to go. This might be the receiver that I would recommend if you were going to place the emitters in the ceiling, because you'll see on the top of the receivers, like on this one and this one, I'm not sure where it resides on this one, but on the top of these two units is where that photocell is, or where the eye of that infrared receiver resides. So with this receiver worn like a headset and your emitters facing down from the ceiling, that's not going to be a concern, because the emitter's up on top of the ceiling and the photocell is on top of the receiver. So aiming straight down at the receiver. So this might come into play where you have left facing, right facing, and forward facing people in the venue. So even if you've got the emitter in the back of the room and they're facing forward, like a cinema or theater or something like that. Okay. Another style of receiver that's on the market, what we would typically call a battery pack receiver. Some of these will use AA batteries. Some of these might use a 9-volt battery. Some of these might use a proprietary plug-in battery. These will probably give you the better reception because they're worn either as a lanyard around the neck, or they might even put them on a pocket, belt pocket or something like that. That's why they call it a body pack. It's clipped to your belt or something. I understand that some receivers are made differently to others. Can you please explain that? E.g., the whole body is the transceiver or is the receiver. I can go in depth a little bit about some of the receivers, but I don't know a great deal about every receiver on the market. If you look at the receivers that I've got here on the wall, on the illustration, what we call body pack receiver, more or less the photocell. Let's go back to the headset receiver here real quick. What we call the photocell, which is what receives the signal, where you'll find them up on top, where my highlighter is here. On the headset style receivers, they're more visible if you know where they are. Like I said, I don't know where it resides on this one. But on this one and this one, they're up on the top. The more visible or the less obstruction to that photocell, the better the reception is going to be, regardless of how that person using it sits, stands, turns their head, right? If you look at the body pack receivers, most of the photocells are on the circuit board itself, residing behind the housing, much like our under the chin style receivers. The photocells will reside, somewhere like right in on either side in here behind that plastic housing. Okay. Same with this. I think this one's actually the photocell right here on these guys. So depending upon where it is, gives some increase of sensitivity, but the actual circuitry is the determination of how sensitive that receiver is going to be. Okay. So if we look at the differences between the size of circuit board I can have for these guys versus the circuit board I could have for the headsets versus the size of our body pack receivers. Okay. I can tell you on our receiver, the circuit board itself is cut out where the photocells reside. So the photocells receive signal from the front, the back, the sides, the top, the bottom. So it's not dependent upon facing the correct way. Now I know there's others on the market that do it as well, including the under the chin style receivers that we were just looking at. Those have a very similar layout where the circuit board is cut out and the receiver doesn't matter whether it's facing forward or backward. It'll still receive its signal. As far as the material that these receivers are made of, most often is the same material that you'll find on the emitter itself. If I can emit through that plastic from the emitter, I'm going to make my receiver out of that same material because I'm receiving the signal, right? If I can emit it through the plastic, I can certainly receive it through the plastic. Some earlier models that we had on the market actually had little windows and openings on the case itself, which really impeded the reception of it, as well as the angle that the receiver had to be to get that signal. So the biggest design part is the circuitry itself and what's used in it. So most of the units on the market I can't really comment on. I don't know the circuitry that well for all of them, but I hope that it answers your question a little bit anyway. Okay. All right. Any other questions anybody might have? Otherwise, we're nearly finished. I'll go through a couple advantages and disadvantages of induction loop. If you read up on the screen right now, the advantages of infrared, we talk about more consistent reception than induction loop. That really depends on what type of loop design has been laid out. If you got a large room with a perimeter loop, obviously infrared is going to work much better. But if you get a large room with a dual phased array, coverage is probably going to be better, if not equal to infrared. Excellent sound quality. We talked about the frequency response between the three technologies. Normally not susceptible to radio interference or interference from other electrical equipment. Can be used in any country. We talked about that. No licensing requirement. There is no frequency restrictions throughout the world for infrared, as there is with FM. Portable systems, we talk about energy efficient. As I talked about with the emitters, if audio is not present for a few minutes, the emitters will shut down, going into what we call a green mode, basically saving about 80% power consumption. Multiple channels can be used, compatible with home TV listening systems. All right. Thank you, everybody who is leaving now. I appreciate your time. Some of the disadvantages of hearing assistance: infrared, too expensive to cover large areas, meaning you might need 3, 4, 5 emitters to cover a large area, like an arena versus a classroom. Emitters can't be concealed. We talked about reflection and stuff. If you wanted to put it somewhere and use a mirror to reflect it, that's one way to conceal it, but we're not going to guarantee the same coverage as we would in an ease plot or an ease diagram. Can't paint the faces of the emitter. The plastic that we're using is specific to infrared and the frequencies that we're using. Opaque objects like a column or something will block that signal, so we might need to take that into considerations. Some receivers require line of sight operation. As we talked about, the lesser sensitivity the receiver has, the more line of sight it requires. I can tell you that our under the chin style is probably one of those receivers that fall into that category. There is receiver management versus an induction loop system where they have minimal receiver. You're also talking about earbuds and distribution of the equipment and receiving it. So when we talked about using your camera or video recorder to determine some problems and issues that you might have, if your client says, well, a couple of years ago this entire room was covered with infrared and now I've only got half the room covered, what's the problem? So taking your camera or your video camera out to that facility, or just having them take a picture and send it to you, you can determine if the diodes are burnt out or if some of them are. If only half the diodes are showing or lit up, you're only going to get half the coverage as you did when all of them were covered, all of them were working. Why is the reception better than one type of receiver compared to another? I just kind of went through that with one of the questions. Really depends on the sensitivity of the receiver, the circuitry, how it's manufactured, how it's designed, how it's built. When should I purchase digital over analog? Really it comes down to how many channels does you or your client need. Again, digital doesn't have better signal strength, it doesn't have better coverage, it doesn't have better frequency response. You're really talking about coming down to, do I need more than 4 channels, which analog covers. So if you're doing a large UN conference where you need 26 languages, absolutely, there's no question about it. If you're going to use infrared, you'd have to use a digital one. So that's really what it comes down to for analog versus digital. I am 2 seconds away from completing this, so if anybody has any questions or comments, I have this up just for illustration purposes, kind of showing you some of the areas where I know that infrared is being used, not just with our equipment, but other people's. Okay. So, with that being said, I would like to say thank you to all of you joining us today. If there are any questions that you might have that have come up after our webinar here, feel free to send me an email or certainly talk with CUK. They can certainly help you out as well. Are there any questions from anybody?
No, I'd just like to say thanks very much, Daryl, for doing that webinar. Really informative. Thanks very much.
Thank you to everybody. Have a great evening. Have a wonderful weekend. And I will talk to you soon, Simon.
Okay, thanks very much, Daryl. Speak to you in a bit.
Okay, give me 5 minutes, okay?
Yep.